I started out the project by using pure ref in order to collect some references in order to build up an idea of what I wanted to create. I already knew that I wanted to make an Archer ability, but the theme was kind of undecided. After I thought about it further, I chose a thaumaturgy theme where the main inspiration was taken from Black Desert Online, as well as a Phoenix ability from the Summoner in Lost Ark. I also used this board to figure out what type of colors I wanted for my ability. And since I wanted to develop an ability that would be for a Black Desert type game, I should also think about allowing the player to dodge out or cancel it somehow. To get myself a character, I went over to Maximo, searching for a Archer type character as well as some animations, which I will be blending with my Deepmotion animation later. The animation I will grab include idle, run, landing, and landing with a roll. This is so I will have some variation and change between the fire animation as well as the dodge animation. Once I was gathering assets, I also went over to Sketchfab in order to find a Phoenix I could use for my main ability. I also ensured that the Phoenix that I want to use was under fair use. And I just want to say thanks Noberto 3D for allowing me to use your model. I then went over to recording my ability so I can turn it into an animation with Deepmotion. My biggest tip for this is to record the movement going sideways instead of towards the camera, as well as having clothes that don't blend with the background. I was actually very lucky that it captured my feet regardless. I then headed over to Deepmotion where I select the character that I got from Maximo and the one that I wanted animations for. I then drag and drop the video that I just created in order to have it produce my animation through the wonders of AI technology. I chose to use FBX output and physics filter. Now, I do want to make a note that if you do have the premium version, you might want to also check the root joint at origin option, as it certainly will make your life a lot easier and you won't have to do some of the dirty fix that I have to do. And here we can see the animation and my video side by side. From there, I just download it as an FBX and move on. As for the packages I used, I downloaded the Fantasy Cave Environment set from Denise Rutkowski and also the Horror Dining Room by Tim Hertel. I use Blender and Unreal to clean up my Deepmotion animation. Blender to edit the sudden joint movements and Unreal to actually change the pose, as it does really well with its blending from the original pose. I created a blueprint for the Archer which derives from the character blueprint. This allows me to use the ability in a game setting if I ever wish to do so. From there, I also create 4 booleans: attacking, using skill, fire, and lastly, dodge. The only other thing that you want to do here is to ensure that the skeletal mesh is the model that we got from Maximo and that we are using our animation blueprint. This leads us into the next part, which is animation blueprint. So to start off, we get a reference to our character by using the owning actor of the animation blueprint instance. So we can also cast to our character in order to grab the booleans that we created earlier. This could be further improved by caching, so we don't cast to our character all the time. Nonetheless, these values will then determine whether or not we will blend into the next part of the animation. As you can see, I've also created matching boolean values in the animation blueprint, as it will make using them in the transitions easier. I've also added 3 more variables, and that is update position, moving, and move dist. These will be used in order to correct the root motion issues that I mentioned earlier. After casting, I set the variables inside the animation blueprint to match the ones of our Archer. This allows us to either determine their value in the Archer blueprint itself, the level blueprint, or wherever I might like to do so, since it's very flexible. I chose when making this ability to create a smaller one first in order to test as well as ensure that my logic was working as intended. And we can first go through that to understand the logic. I created a sequence node which leads into a branch, checking if the Archer's boolean of attacking is true. If it is, then we'll set our animation's blueprint's value to true. We will only do this once in order to prevent the attacking animation from starting over and over again, as we can see here. You will see that I use this method for the main ability, although we have to check for more things, such as the time remaining or dodge, to name a few. So now getting into the main ability. From the second execute pin in the first sequence node, we go into a branch where we check whether or not moving is true. If moving is true, then we go into a new sequence node where the first pin goes into a do once, which then the completed pin goes into a set variable node. more specifically our move distance variable. We then get our location of our character and add a value onto it. This is to move our character forward when the skill is initiated. From our secondary pin, we go into a set location node which utilizes the move distance that we just set. From there, we lerp from our current position into the new one we just set with a interrupt speed of 3. This value might change depending if your walk animation is a bit faster or if the distance is smaller. If the moving is false, however, we'll reset the do once because it either means that we have finished the ability or it has not been used yet. If we take a look at the animation graph, we can see how the blend tree functions with our main ability. Just like I mentioned before, this is really just an upscaled version of the experiment that I just showed. So with that said, let's take a look at some of the transitions. So now I'll just show you an example of how the booleans really alter the direction it will take during the transitions I just showcased. I also used anim modifiers to fire certain actions, and this is why you saw, for example, when I pressed use skill or other booleans, they get turned off once their action is considered complete. Here we can see how the anim notifier will fire at certain points of the animation. These anim notifiers are responsible for a whole wide range of things. One of which is launching the character and altering its gravity in order to give it more air as well as make the ability feel like it's being held. Other actions I use anim notify for is, for example, updating the position of the character depending on whether or not they did the roll or fired the ability, as the animation distance is a bit different depending on the ability. And then you have the end ability, which resets the actual ability as well as the rest of the booleans. As far as the Phoenix blueprint goes, it's almost identical to the Archer blueprint, with the exception of having a pawn as the parent class, as well as a function in the start, which is just really to set the position of the Phoenix behind the Archer, regardless of where it is in the world. Just like the Archer blueprint, we start by creating some booleans, which we can use later in the animation blueprints. The blueprint basically gets a tiny delay to ensure that our Archer has been spawned and that we can get the position and the rotation from our Archer. All we do from here is set our Phoenix to match the same, but finally we'll add an offset of -230 on the X and -200 on the Z. From there I went over to developing its animation blueprint, and it follows the exact same pattern as the Archer. So I'll be going through that a bit faster. We start off by getting a reference to the instance and use that to cast to our Phoenix in order to grab its variables. From there, we go into a sequence node that checks if we are resetting the ability. If we are, then reset the bools. From the second pin of the sequence node, we head down to the do once and put it into the reset part of it. The reason why we want to do this is so we can spawn a new particle system and hide our birds for each time we do the animation, because the destroy bird will always be called once we've either done the dodge or the time has run out. Now, if you further want to optimize both the Archer animation blueprint and the Phoenix animation blueprint, you can easily do so by caching a reference in the event blueprint begin play and skip the cast that we do at both of these updates. Though do keep in mind, it is good practice to make something functional before you start cleaning things up and refactoring. The animation graph for the Phoenix is also pretty much the same as our Archers. However, it does have some fewer animations to blend, and same goes for the transitions. They are fairly similar, but a tiny bit of change. So we can take a look at them as well. Now, for me, just having one animation for the Phoenix wasn't really enough. It didn't really sell the ability and that it was alive. So I chose a Phoenix that was rigged, since I could quickly make some animations if they weren't already included. I was lucky that the animation of the Phoenix flying was included. However, I had to make my own animation for spawning as well as attacking / being launched. And once I had developed my animations, I exported it as a FBX and imported it into my engine using the skeletal mesh I already had, so I wouldn't create any duplicates. So that's what these animations are. For the Phoenix Destruction / Dodge VFX, I created a Niagara system which uses a directional burst emitter as a template. Here I edit the values to better fit the look that I'm going for. For example, changing its color over time, we change its size over time, and we also change the highlight and the fade. Ensuring to set the coordinate space to simulation. This is going to be very important, as you most probably want the VFX to actually explode over the character, else you might have some funky rotation values. It's also very important to change in the emitter properties to use local space. To develop the VFX which covers the Phoenix skeletal mesh, I created an emitter. In the emitter spawn setting, we set it to spawn burst instantaneous, and the only other things you really want to do here is to add a initialized mesh reproduction sprite in the particle spawn, as well as a update mesh reproduction sprite in the particle update, and also ensure that you have a sprite renderer in the render section. Then I will create our system and click create from emitter. This will allow us to select the emitter that we just created in order to quickly get it into the system. And now that it is a system, we can also easily put it into our scene. Firstly, what I will do here is I want to create a user exposed variable, so we can grab a reference to our Phoenix in the scene. I will then set the variable as the one to use in the initialize mesh reproduction sprite, as well as the one in the update mesh reproduction sprite. So now that we are using the variable in one of the emitters, we can copy it and create our variation. This variation includes, for example, the spawn amount, the spawn size, the size over time, the rotation, and also go as far as changing the mesh reproduction values. Finally, I go into the sprite renderer and change out the material for both of these. And I set the material to the one I've created instead of the default one. This moves me into the particle material. For the red material, I start off by setting a color and multiplying it with a texture object, which kind of has some spots in it. This I use in order to get some black colored spots or darkened color spots. And as you can see here, we have a radial gradient exponential. We use it for cutting off the edges, so it has a smoother fade out. And this is so we don't have to use the scale color over life to do anything like that. It also gives us a much softer look to the blood. And since we have so many particles, this gives it a really nice look. The only other part here you can see is that we have a low roughness value, and then we also have a multiplier on the opacity mask. And that is just so we get some fading, but not too much. And for the black blood material, it's essentially just a simplified version of the red blood cell. So we have a almost black color that goes into the emissive color and a radial gradient exponential into the opacity mask, this time without the multiply. I also created two sequences that I use to control the movement of the Phoenix. One is for the spawn and the other is for the attack sequence. Like I mentioned, I use these to change the movement, but in the attack sequence, I also change some post-process stuff. This includes changing the intensity of a light above the Archer, the color of the light, the bloom on the post-process, the motion blur, and finally, exposure. Now, for the creation of the fluid, I created the fluid simulation in Blender, and I did it by first creating a mesh, sizing it up to the size that I wish to have it. And this is basically going to be our simulation environment. From here, I select the particle menu, select fluid, put it as a domain, as this is what will host the particle. We set the type to liquid and enable mesh. Nothing more has to be done here, though we can set the final frame to 50, for example. We're now going to create our icosphere, which will put a fluid system on it and put it as flow this time. Put flow type as liquid and set the resolution divisions to 32. And from there we have our simulation. Now it's just to export it. Now, before we head off and export our alembic file, we have to add a modifier of smoothing. If we don't do this, we're going to get a bunch of errors and it's not going to export correctly. So let's add a modifier and click apply on it. It doesn't even have to do anything, it's just an Unreal Engine quirk. Then we save out our file, ensure that we have selected all of the stuff that we have to have in it. Set the end frame to 50 and export. As far as importing goes into our engine, we just want to set the import type to geometry cache, experimental, and then just ensure that our frame end is the same as the one that we exported as, because sometimes you might put it at 1. Click import and let's check it out. Now, something you might notice is that the performance is quite frankly shit, and we can't really use that in a game, much less anything else really. Luckily, I found a solution and a fix for this issue. So what we want to first do is we want to ensure that we have the smoothing done correctly, like we did with the alembic export. And instead of exporting it as a alembic, we want to export it as a OBJ. This will then create the entire animation that we had as objects instead, which we can then import into Unreal Engine. And in Unreal Engine, we'll create a actor blueprint. Here we will just ensure that we have a static mesh component. Here I will also create 4 variables. One I'm going to call FPS, the other I'm going to call mesh array. The other 2 are going to be Boolean values, which is going to be sim begin on play and reversed. As for the mesh array, we can fill it up with the meshes that we just created. However, I do want to point out that in the initial mesh, we select our very first frame. Then in the mesh array, we ensure that we select only from the second frame and above. That way we're going to get a smooth transition from the very first to the very last. Now, since the alembic export did not work out for us, we now have to loop through each one of these and set them as our static mesh. We have to do this at a very specific time interval. Unlucky for us is that the for each loop in Unreal Engine does not work with a delay. So we have to create our own function for this. I did this by copying the for each loop function. As we can see here, we pretty much have it here, and I would not recommend to change the one that's already built in the engine, because a lot of stuff can break here, but rather create your own function based off this. So you can copy it and then create your own function with it. And the only really difference that you're going to make in that is that you're going to add a delayed node here, which you can now see that I can plug my FPS into it. Now, the only other thing that I had to do for the FPS was to set the value to match 60 frames per second, and that is simply done by doing 1 divided by 60. And that is how we get that value. So now let's take a look at the spawn simulation function. We started off by checking if the simulation has been reversed. If it has been reversed, then we will reverse the mesh array once again in order to make it go the correct way. And then we set reverse to false. And if it's not reversed, then we just loop through as we normally would. Once we have completed the simulation, it will reverse the simulation automatically. And I do this by simply reversing the logic that I already have. So instead of coming out of the true on reversed, we just go out from the false and do the exact same thing, and then set reverse to true this time. And that's really it. I do also want to make a quick point that if you even further want to improve on this system, you can by adding nani to it. And that will ensure that the simulation is only ever going to drop about 1 frame. And that is pretty much a huge improvement from the alembic export, where it dropped an insane amount. Unlike the particle materials, this one is a bit more complex. Our material is procedurally changing, albeit very slightly. I've also edited the roughness of the material with a sine function to give it that ever-changing look which Fluid often has. The texture animation is done with a panner as well as a opacity mask for it. But yeah, other than that, we can really see how each node really contributes to the final look of the material itself. I also wanted to ensure that my abilities had a hard impact and make it more cinematic. A way of doing so is by creating camera shake and some FOV shake. The frequency of the values are procedurally set with Perlin noise. However, I have set the min and the max threshold, which you can see here. First, take a look at the camera sequence shake, and then let's take a look at the FOV shake. It doesn't have any rotation, it doesn't have any location, it's strictly working on the FOV. However, I did find that this was the best timing for my ability. As for the camera sequence shake settings, as you can see, we're using the Perlin noise, and then we have set some default values, and then we have some timing here. This timing really depends on my ability, and also I had to change that a tiny bit for the FOV because I only wanted it to be in the start, not too much in the end. For the level blueprints, we have a event begin play where we gather references, as well as set some of our variables, like for example recorded position, so we can always reset the animation and also just in general start over if we ever want to. And then we hide the Phoenix and we hide the VFX system that we created. Other than that, we create a level sequence player, both for the spawn and for the attack sequence, and grab a reference to them. We also have a dirty fix by disabling all screen messages, and that is just to prevent any debug logs to appear on the screen during our final render. To start the sequence, we have an input action of shift right mouse button. This is created by going into the project settings, selecting input, and creating our own action mapping, where we then input shift and right mouse button. The reason why I wanted shift and right mouse button is because in Black Desert, often those are your very strong abilities. So I wanted to kind of follow the same theme here. And the first thing we do here is that we check our Archer character if we are using skill. If it is true that we are using skill, we don't want to do anything because we are obviously in the skill animation already. If we're not, we're going to set using skill to true, but we're also going to have a camera shake, and this is where the FOV shake comes in. We also have to have a pretty hefty outer radius, else it's not gonna always hit the camera when we're doing our cinematic shots. Other than that, we also want to set our simulation to not hidden anymore if it is. And then we want to call our function that we created, which is the spawn sim function. Then after a certain delay, we want to spawn our Phoenix, and we do that by setting them to not being hidden anymore, but since we already placed them under the map, they're not gonna show. We then set the Phoenix's start combo to true, and from there head into a sequence node. From the first pin of the sequence node, we're going to play the movie of spawn sequence reference. The only thing that's going to reset this is if we press R, which is our reset button, but we'll get to that. In the second execute pin, we head into a delay before we set start combo to false, and this is to prevent it from looping all over again. We just want it to play once. The delay is there just to ensure that the animation will play. Heading down to our reset, we use the input button R in order to reset our position of the character. We reset our Phoenix, and we also hide the Niagara system. And we also want to set the reset variable in the Phoenix to true, because then we reset all the animations that we have for the Phoenix. And when we release the R button, we then want to set reset in the Phoenix to false. This is the pin that will then go into the reset of our do once that we just had. For our dodge, I use the button number 2, and that is just to easily call it. And from here, I set in our Archer and in my Phoenix to dodge true and dodge false when released. Now, if we are in the using skill animation and we press either the left mouse button or the right mouse button, we want to fire our Phoenix. But first, we want to use a small delay to allow the animations to mesh with each other. We will then go into setting fire to true in Phoenix, stopping the spawn sequence and moving on to the attack sequence. From here, we will then set a delay, and the duration of this will be based upon the duration of our attack sequence. This is in order to always get the world camera shake at the end of the sequence. And the shake that we will use here is the camera sequence shake, since we want to ensure that a player can still instantiate our ability, but still get them shots. Instead of using a cine camera actor, we create our own pawn. This will then allow us to fly around and also ensure that our inputs are still being checked. For this, I created a pawn blueprint script, where in the components tab, I created a cine camera. This allows us to still put on image effects if we still desire that. As far as movement goes, it's very straightforward. We move fast when pressing left shift button, and that is done by simply changing the variable that we have for move speed and hover speed to something higher and lower them once we release it. It's really not that crazy. The input axis move forward and the input axis move right takes our wasnt input and adds a world offset. It's very important that we use world offset here and not the local offset, since if you don't, you will not get the desired movement. For the mouse movement, we add input from look up and turn to our local rotation, which we then use a set rotation in order to clamp the pitch and set the rotation. Up and down movement is based on a input that I made in the project settings. Here we take the axis value and multiply it by hover speed so we can move faster if we press shift, likewise for hover down. A final error prevention that we can put in as well is to flip-flop between movement disabled and movement enabled. Now the final step is just to set it as our player in the world settings, and let's collect our shots. Now if you do wish to hire me, here you have my contact information as well as my GitHub, so you can check out the other stuff that I do. And yeah, that's it. Thanks for watching.